Sinusoidal and harmonic quantities. Okay, so lovely people, welcome to another episode, and today we're dealing with the sinusoidal and the harmonic quantities. Under the sinusoidal quantities, we have the voltage quantity, and also we have the current quantity. Okay, so now we like that with the sinusoidal, we'll be dealing with the sinusoidal voltage quantity and also with the sinusoidal current quantity. So now what happens is that when you have our sine waveform, so this is our sinusoidal waveform, we obviously have a peak voltage, and now when it's voltage, we represent by Vm, and also to when it's current, we represent by the Im. So this is the voltage. So now the quantity, that is the equation of the quantity, is Vm sine omega t, or the quantity I becomes the current Im sine omega t. So now what happens is that the Vm is the peak, the Im is the peak current, this is the peak voltage. This one is the angular, that is the omega, that is the angular frequency. But the omega is simply equal to 2 pi f. So therefore the function voltage quantity can be Vm sine of 2 pi f t, or Im sine of 2 pi f t. Okay, so now with this, we can find we want to find the RMS value for a sinusoidal quantity. If you have a sinusoidal quantity, either the voltage quantity or the current quantity, how do you find the RMS value of a sinusoidal quantity? Okay, so now what happens is that before you say you can find an RMS value, you are using the voltage. We said we have to square the function. The function has to be squared. So now we have the function v of t as Vm sine 2 pi ft. The RMS voltage said, the rule said, the V RMS said is is the root of 1 on t, integral of 0 to t times the function, the square of the function dt. We've established this already in previous lessons. So now, how do we go about this? How do we go about this here? So now you have to square this function. So when you square this function, what are we getting? We are getting Vm squared sine squared 4 pi ft. So now this is the function you square. So if you square this function, then the Vrms is now equal to the square root of 1 on t, integral of 0 to t, Vm squared sine square 4 pi ft dt. Okay, so with this, what happens is that we can find the Vrms, which is equal to the square root of 1 on t. So now the Vm squared is a constant, so you can find Vm squared integral of 0 to t. You can change this sine square 4 pi ft into 1 minus cos 4 pi ft all on 2 dt. Now 2 is also a constant, so we can get now our Vrms, which is equal to the square root of 1 on t times Vm. 2 is also constant, so you can come here, integral of this 1 minus cos 4 pi ft dt. Now with this function in the bracket, with this function, when you integrate this function with respect to this limit 0 to t, when you integrate this particular function, you will get t. So now when you integrate, you get 1 over t Vm, that is Vm squared So Vm squared on 2. When you integrate this whole function with respect to this limit, you will get t. Okay, so when you get t, then this t can take this t away. So your final Vrms becomes root of Vm squared on 2. So your Vrms now becomes Vm on root of 2. Vm on root of 2. So therefore, anytime you want to find the RMS voltage, is equal to the peak voltage Vm on root of 2. And the same way, if we have to go through the current, the sinusoidal current quantity, we end around finding the RMS, IRMS goes what? The peak current divided by root of 2. And this is how you can find the RMS values for a sinusoidal quantity. Okay, let's know it once time. Let's look at how you can find the RMS values for a harmonic quantity. And what is a harmonic quantity?
Now, non-sinusoidal periodic voltages and currents can be expressed as the sum of sine waves, in which the lowest frequency is f and all other frequencies are integral multiples of f. For example, you can have a square wave v of t of amplitude e, and that square wave can be expressed as harmonics. Any quantity which contains multiple frequencies is a harmonic quantity. The frequency of which others have been expressed as multiples of is the fundamental frequency. An odd multiple of fundamental is an odd harmonic, and an even multiple of the fundamental is an even harmonic.
So from the definition of the harmonic quantity given in the slide, you realize that when you have your fundamentals, you can be having what we call the odd harmonic, or you can be having what? The even harmonics. Okay, so now any of them do. So let's take an example. If you have an amplitude function, let's say of E, a function of amplitude E, then that function can be written as 4E divided by pi in harmonics. So sine of 2 pi f. So this, you are giving odd harmonics, that is odd values. So plus 1 on 3 sine of this 3 will be what? 6 pi f. So we assume that here was 1 on 1. Okay. So another plus in harmonics, so even, so another odd again, which will give what? 1 on 5. And this 5 will affect the value here, which is what? Sine 10 pi ft. We can also have 1 on 7, which will have sine 14 pi ft plus on and on and on. So this is an harmonic. This is an harmonic quantity. Now, if you have an harmonic quantity of this nature, how will you find your root mean square value? How will you find your root mean square value? Okay, so find the root mean square value of an harmonic situation. This is what you first do. So assuming you have this as a quantity, as A naught plus A1 sine bracket omega plus a phase angle plus A2 sine maybe 3 omega t plus a phase angle plus A3 sine maybe 5 omega t plus a phase angle. If you have something of this nature, you are asked to find the root mean square of this harmonic, then the root mean square, the VRMS, will simply become the square root of their RMSs. So if you take any of them, you realize that any of them, each portion of them or each term of them is a sinusoidal quantity. So you have to find the VRMS of each of the sinusoidal quantity. And upon doing so, you'll be able to find their total RMS value. Okay, so to do that, what happens is that this should be squared. So the RMS value of here, that's A naught squared, plus a1 on root of 2. So if you consider this value, this is the peak value. So assuming we're still having the Vm sine omega t plus this would have been the peak value. So the Vn RMS value will become Vm on root 2 as we found. So that's what I've done here. So square plus a2 on root 2 also square plus a3 on root 2 also square. So this will be the value to finding the RMS value of an harmonic quantity, a quantity that is repeating in the harmonic. Right. So let's take a typical example. Now, when we have this question as find the effective value, so find the effective value of this harmonic. Find the effective value of this harmonic quantity. I of t is equal to 2 plus 5 sine omega t plus 3 root 2 sine 3 omega t plus a phase angle of 103 degrees. Okay, so if you have this and you have to find the root mean square value, then our IRMS, that is the effective value of this harmonic quantity. In simple terms, effective value of this, you are finding the effective value of this current on the American quantity, which is equal to the square root of, so we said the constant, we have to square it. So 2 square plus 5 on root 2 all square. So this is the peak value here for this quantity, plus this is the peak value for this whole quantity. 3 root 2 on root 2 all square. So when you do this, you are getting 5.05 amps. Yeah. This one will take this away. So when you do that, 3 squared, that is 9. When you simplify everything, you are getting 5.05. And this becomes the root mean square value of the harmonic quantity. I like you to get a lot of questions. It's not really difficult. You just need the understanding to solve it. So you get a lot of questions and deal with it. Thank you very much for this episode.